This is section 2.2, number 43. They ask us to find the derivative of this, and so I'm just trying to pick some problems that I see maybe something a little different on, just to kind of show you how you take care of it. Now, if we remember back to what we were doing when we were evaluating limits of a function, if there's something we could factor out, we want to do that. We could cancel stuff out. Well, nothing factors out here, but here's what I can do. It would be easier for me to differentiate this if I could have it written in a different way. There is a way to do this, but it's not fun. So we're going to do it the easy way. We're going to say if I have some things, all those terms on top of that fraction, they each have that denominator of x squared, so I'm going to split them up like this. So when I do that, just put each one of them over x squared, some things cancel out, but they turn into something much easier to differentiate. And it's an equal expression. X cubed over x squareds cancel out, you got an x left. These x squareds cancel out, I have minus 3, and then I have 4 over x squared, which I'm going to write as 4x to the negative 2, so I can use that power rule, or that chain rule, I think it's called. Okay, so now all I've done so far is just rewrite the function. That's why you're going to see on some problems, like in 25 through 30, they actually are trying to get you to think that way. Can I rewrite it first? Then let's differentiate it, and then if I need to simplify it, I will. So if I differentiate, the derivative of x would be 1. The derivative of constant would be 0, which I'll just write here just so you can see that all the terms are here. And then the derivative of 4x to the negative second power, I'm going to go, there's a 4 out front, but I'm going to multiply it by the exponent negative 2. That's going to make a negative 8. And now I'm going to subtract 1 from my exponent. So negative 2 minus 1 would be negative 3. So my derivative is just 1 minus 8 over x cubed, because I'm just going to rewrite this term in this form right here just because it's the polite way to communicate in math. So it may be polite to communicate one way, but just like you might say something in private that you never would want to say out in public in front of someone else, when we're working on functions, we deal with them as the exponents are negative because it makes it easier. But when we go to present it out in public, we write it in a nice format. That's why we actually rewrite these things. That would be good to look at would be 45, just in case you kind of look at it and go, what am I supposed to do here? You got two things multiplied together. Well, you could distribute, couldn't you? We don't know what to do when we have two things multiplied together yet. There is a rule coming up. But even when you learn that rule, you're going to see the easiest way to do this would be just to go ahead and distribute. That would be x cubed plus x. So factored form isn't always the easiest way to deal with functions, especially when you're differentiating. Now, here's my function. That's just the function rewritten. And now I'm going to take the derivative of it. I would drop the 3 out front. That's 3x squared. And then the derivative of x is just 1. And you're done. On 47, you have f of x equals square root of x minus 6 cube root of x. Okay, so what I'm going to do is rewrite this one also, because if I can make some kind of exponent up here, I can differentiate much easier. The square root of x is the same thing as x to the 1/2. Minus 6, the cube root of x is the same thing as x to the 1/3. We did this back in Algebra 2. I just don't know if you remember it. All right, so now I've rewritten it. Now I can use that chain rule, okay? The chain rule says if I differentiate, I drop the 1/2 out front, and I subtract 1. Well, I'm going to get a common denominator. I'm subtracting 1, but it's really 2 over 2. 1 minus 2 would be a negative 1/2. Same thing here. I drop my 1/3 down. I'm going to multiply it by 6. Do that in another step here. And then if I subtract 1, I'm going to write that 1 as 3 over 3. I'd get negative 2/3. So let's clean this up. This would be 1 over 2. Remember, the negative exponent goes to the bottom, and I can rewrite it as a square root of x now. And then 1/3 times 6 is 2. And then I've got x to the 2/3 on bottom, which I could write it that way, or another way I could write it if I want to use all similar radicals. Sorry, I did not mean to make that. Let me get rid of some stuff here because I made my little fraction line too long there. Go ahead and pick this again. That would be negative 2. I'm sorry. Man, I can't keep from making mistakes right now. This would be 1 over 2 square root of x. I'm just going to come down here since I'm I'm having trouble doing it the other way. Minus 2 over, now if you remember how this, you could also write this is the cube root of x squared. If you remember from your algebra days, this was the root you're taking, and this is like the power you're raising the variable to. So I could also write my answer this way. Either this way or this way would be correct. I would just go kind of, you usually don't want to leave a mixed radical and fractional exponent. It's just kind of being really lazy to do that, and we try to be nice about the way we present our work in public. Thought I would do one like number 55, because 55 has an additional step on it. It wants you to find the equation of the tangent line to the graph at a given point. Well, if I'm going to write the equation of a line, I need a slope and I need a point. And they give me a point. They tell me the point is 1, 2. So I'm just going to go ahead and write that. I know when I get done what I can do is use the point slope form. I just got to find the slope. And I can plug this stuff in, right? I could go ahead and say that's y minus 2 is whatever the slope is times x minus 1. And then when I'm finished, I'll write my answer here. All I got to do is put that slope in front. Well, here's the equation they give me. F of x is 2 over the 4th root of x cubed. So we're going to rewrite this. This is 2, and I could rewrite the 4th root of x cubed as x to the 3/4 power. But in order to differentiate it easily, I'm going to write that as 2 times x to the negative 3/4 power. Hopefully by now you're starting to see the usefulness of negative exponents and being able to go back and forth. And sometimes when you're learning that stuff back in 8th grade, 9th grade, you kind of think, why? Well, now you can see the usefulness of it. I really don't think you start understanding why you do things till you try to use calculus. All right, so let's take the derivative. And the derivative is going to be an equation. It's not going to be a number. We can find that number, though. So negative 3/4 times 2, let's see, the 2 and the 4 would reduce, it would be negative 6 over 4, which reduced to negative 3/2. So out front, I'm going to have a negative 3/2 when I multiply 2 times negative 3/4. And then I'm going to subtract 1 from the exponents. My common denominator would be 4, so I'm going to subtract 4 up here. I'm just going to kind of write it up here so I can think. Negative 3 minus 4 would be negative 7/4. All right, so that's it, though I might want to write it this way. That's negative 3 over 2x, and it's the 4th root of x. See if I can cram that in there, 4th root of x to the 7th power. And write that bigger so we can read it. Negative 3 over 2, the 4th root of x to the 7th power. Now, that's the equation for the derivative, but I don't have the derivative at that point yet because I need to plug in the point. I need to plug in what x do I have here. I have the x of 1. So let me do that, and it'll show up in red. That's 2 times the 4th root of x is 1 to the 7th power, which would just be 1. Well, the 4th root of 1 is just going to be 1. So I have negative 3 over 2 times 1, which is negative 3/2. Okay, so my slope is negative 3/2. I had to go through all that work just to find it, though. And once I find the slope and I plug it in up here, I'm done. That just was the missing piece I needed. This is the equation of the tangent line to the function at the given point. It contains the slope of the function at that point. That we consider the slope of the function at that point to be the slope of that tangent line. And so that's why we keep talking about tangent lines, and that's why we need to understand the derivative gives us a slope, but it gives us an equation, not a number. So to get the number that I want from my equation, I need to plug in the x of the point that I'm looking at, because that slope's changing all over that graph. It won't be a constant number. Hopefully this will help you get through some of the problems and kind of look at how to attack things. I don't want to do everything for you, and I know you have the answer key anyway, so